Warm greetings. Welcome to Swayam Online Learning Portal. I am Dr. S. Ishwari, Head of the Department of Geography, Madras Christian College. In the previous lecture, we have discussed about the forces acting on wind. In this lecture, we will be discussing about jet streams. What are all the contents we are going to discuss in this jet streams? That is, how the jet stream origin and how the jet streams have been discovered, and what all the types of jet streams and the seasonal shift of jet streams and significance of jet streams. So, these are all the contents we are going to discuss in this lecture. Geostrophic wind. You may wonder why instead of jet stream, this geostrophic wind is again here. So, there is a reason, that is the wind speed and direction are controlled by combined action of wind generation forces. So, that we have discussed in the previous lecture in the forces which initiated the wind. That is, the most important forces are the two primary forces, that is pressure gradient force, that is PGF, and Coriolis force. So, this is the two primary forces which initiate or which influence on the wind. The pressure gradient force initiates the wind by moving air from high pressure towards the low pressure. So, usually what we imagine that if the pressure is moving from high pressure area towards the low pressure area, it should be travel vertically like this, but it is not so in the geostrophic wind. What happens? It is diverting here. Why it is diverting here? It is deviating because of this Coriolis effect. So, this Coriolis effect plays an important role in geostrophic winds. That's once the air start moving, the Coriolis force alters the direction. So, once the air is moving here, this Coriolis force influence and it divert this air movement. That is, the wind deflects the right side in the northern hemisphere and left side in the southern hemisphere. So, as wind gains speed, what happens? The Coriolis deflects, the reflection is increases. The wind speed is directly influencing the speed of the Coriolis force. The geostrophic wind, that is, it deflects continues until the Coriolis force balances the pressure gradient force. In the previous lecture, what we have discussed, that is, the Coriolis force balances the PGF, that is, it equals to PGF, that is, this balance occurs about 2 to 3 kilometer above the ground. So, where the friction is negligible. So, we know that nearby the earth surface there will be a frictional force. So, due to these forces there is a equilibrium effect. At this equilibrium, the wind flows parallel to the isobars. So, if the isobars are generated like this, so the wind is also moving parallel to this isobars. So, and perpendicular to the pressure gradient, and it was somewhat perpendicular to the pressure gradient. So, such a balanced friction free wind is known as geostrophic wind. So, these are all the process which involves to generate this geostrophic wind. Now, coming to the jet stream, the geostrophic wind is nothing but it is one of jet streams. So, because of this, we have discussed first initially in the jet, that is geostrophic force, in the initial slides. The jet stream, the word jet means the high speed and stream means the narrow channel. Stream, you know that fluvial action, river action, the stream. So, this is the meaning of jet streams. The jet stream are geostrophic wind. So, geostrophic wind which flows horizontally in the upper troposphere, where this wind is prevailing in the upper troposphere. In the layers of atmosphere, the troposphere is the lower layer, the first layer of the atmosphere. They occurs as a narrow band of extremely fast wind. So, how the jet stream will be there? See here, it is a narrow, but it is not, it looks like what? It looks like a ribbon. So, it looks like a ribbon structure. So, you can see the strips of jet stream in this diagram. It generally, the term you have to notice generally from west to east, due to the Earth's rotation. It is not in all cases. Generally, the movement of jet stream will be from west towards the east direction. It's located at 20,000 to 50,000 feet altitude. So, this jet stream is in this altitude. And then the jet streams develop where the air masses of contrasting temperature meets. So, where the jet stream originate, where the warm air parcels and cold air parcel meet, in that particular place this jet stream is prevailing. That is most important. So, in this diagram you can see that from Hartley cell and this Ferrel cell, what happens in the Hartley cell, there will be a low pressure. Here you have the low pressure and the temperature will be high because of the influence of tropical region, that is the equatorial region. And here you have in the Ferrel cell you have high pressure. So, the temperature will be low here. So, these two have the contrasting nature of warm and cold air parcels. So, here you have warm air, here you have cold air. So, these two warm and cold air meet here and forms a vacuum here, the stable here, a blocking here. So, that forms the jet stream in this region, that is subtropical high region. And again it does not stop with this region. Again here also in the Ferrel cell you have high pressure, and in the polar highs you have the low pressure. So, this warm air from Ferrel cell and cold air from polar cell meets together in this point. Again the same characteristics is formed here in this region, that is polar front region. So, here also you have the formation of jet stream. So, it does not stop with this two major jet streams. It have locally impact also. So, in a local region it's impacting. So, because of that there is a few other jet streams also emerges. So, we will be discussing that one in detail in upcoming slides. The surface temperature contrast plays a key role in the jet streams. So, because of the warm nature and cold condition. So, that surface temperature is most important in generation of jet streams. The greater the temperature difference, higher the wind speed will be in the jet streams. And then the jet stream generally extend about 20-degree latitudes to the poles in both the hemisphere. So, in the northern hemisphere also from 20 degrees towards the pole, and in the southern hemisphere also 20 degrees towards the polar region. Origin of jet stream. So, you can see in this diagram that the main cause is that the warm and cold air mixing. So, this warm and cold air mixing takes place in the diagram 1, and then in the fluvial action, in the river action, you might have come across the process, that is the meandering. So, meandering will be taking place in the river action. The same way here also you have the meandering process in this jet stream. So, in the second stage you have the meander formation and then because of the intensity of the wind, again this meandering will be somewhat high, intensity will be high, and depth of the meandering will be witnessed in this third stage. And in the fourth stage, in the meanders, what happens? The meandering in a particular stage. So, because of this velocity of the wind, the speed of the water, it forms the oxbow lakes, meandering of the streams. In particular stage, what happens due to the flow of water, the streams, it have formation of oxbow lakes, and there is a different path of the meandering of that particular stream. So, that same process prevail here due to the intense velocity of wind. Force of the wind, what happens, the jet stream will be flowing here, and then here you have the high and low pressure like oxbow lake, it have like an island of high and low pressure. This high and low pressure circulation spirals is nothing but it is a formation of cyclones and anticyclones. So, these are all the 4 stages of jet streams. How it originated? It originated because of the thermal gradient, that is there is a difference between the heatness from equator towards the pole. So, because of this difference it influences the jet stream. And the pressure gradients also plays an important role between the pole and equator. So the pressure and temperature is a vibrant forces which initiates this jet streams. The pressure gradient between the surface and subsurface air over poles is one of the most important factor in origination of jet stream, and it is also most important that to understand the Coriolis force which plays an important role in origin of jet streams. So these are all the important triggering factor which influences the formation of origin of jet streams. Discovery of jet stream. How it is discovered? That is, the jet stream were clearly recognized during World War II. So in the World War II period, this jet stream have been witnessed by American fighter aircraft. So American flights have been traveling, and some disturbance was there in the flight traveling. So that was witnessed by the Americans while traveling over the Japan. So that disturbance is nothing but that disturbance is jet stream. So before this discovery, earlier also it had been identified before this period, that is 1904, it had been identified, that is it came from the studying of high speed cirrus clouds. So the high speed cirrus clouds while studying this clouds, there was an discovery of this jet stream in that particular latitudes. So the cirrus clouds forms above 6,000 meters, indicating the strong upper level winds. So that strong upper level winds was nothing but it is a jet stream. The name jet stream is mainly based on the analogy, that is fast flowing water jet. So how the water jets will be very fastly moving, that great fast is influenced in this jet stream. Because of that, the name is given as the jet streams. The types of jet streams, initially we have discussed about the two major jet streams. So based on the locational aspects, there are five types of jet stream, that is polar front jet streams, that is low pressure, subtropical westerly jet streams, that is high pressure. Here you have the locally influenced jet streams, that is tropical easterly jet stream, polar night jet stream, cross equatorial jet stream. So we will be discussing this one elaborately one by one. So polar front jet stream. The polar front jet stream is the polar jet stream was discovered by Carl Gustav Rossby. So the Rossby wave. So that is the most important here. It is also known as the primary jet streams. So this polar front jet stream is known as primary jet streams. The average speed of it is 215 kilometer per hour. So this is a gusty wind. Not only it stops with 215, sometime in some cases the speed can reach nearly twice the average. So the speed of the wind also increases in some cases. The horizontal length of the jet stream from 1600 to 3200 kilometers, and the vertical depth will be relatively very small, that is about 1 to 2 kilometers. The next one is subtropical westerly jet stream. That is, the subtropical westerly jet stream originate in the meeting point of Hartley and Ferrel cell. So in the previous slide we have discussed this one. So because of high pressure and low pressure, the warm air and cold air meet in between these two cells. So in this meeting process, there is a emergence of jet stream, that is subtropical westerly jet stream, on account of the permanency of the Hartley cells. So Hartley cells, it's not disappearing, it will be a permanent in nature. Because of this permanency, what happens, this jet stream is intense throughout the year. So all through the year this jet stream will be prevailing. Although with the shifting of the pressure belts, its path will shift north and south. This shift of north and south is mainly because of apparent movement of sun. Tropical easterly jet stream. So this is the next jet stream, that is this jet stream will be prevailing locally. So in the local basis it's prevailing. This tropical easterly jet stream, that is TEJ, is located at the altitude of 10 to 12 kilometers. So this is the height of the tropical easterly jet stream, and it flows above the Gangetic plain. So how it's roughly parallel to 25° north latitude. So this tropical easterly jet stream developed during the summer season because of what? The Tibet. In the Tibet you have the low pressure. So this low pressure, the intense heat in the Tibet, which influences this jet stream, that is tropical easterly jet stream. So it is very interesting to note that in the northern hemisphere, how the wind will be traveling. It will be traveling because of Coriolis effect in the right direction, right side direction. But here you can see it's traveling towards the western side. That is, this is the major change. Why this change is because it originates due to intense heating in the Tibetan plateau, which creates the strong low pressure converging system here. Here you have the low pressure. So because of that, what happens? There is a apparent movement of the ITCZ, that is in the equatorial region. There is an apparent movement of this wind. So the wind, because of it influence, this low pressure influence with the westerly wind which travels above this low pressure, and it forms the spiral movement here, and this spiral movement in turn it deflects towards this western side, southwestern side. So this southwestern side wind which reaches here, again that is due to the heat and due to the apparent movement of the shift of the ITCZ, what happens? It again rising here and forms the southwest monsoon. So this process we will be discussing again in the southwest, that is monsoon topic in the lecture to come. So here you understand the basic concept how the southwest monsoon emerge throughout the globe, especially in the subcontinent of India. It arrives the onset of the southwest monsoon over Indian subcontinent. So this entire process, low pressure, high pressure, and then the shifting of the wind, so collectively gives the onset of the southwest monsoon wind. The polar night jet stream. So in the name itself you have the polar night. That is a polar night jet stream during the winter season over the polar region. So in winter season, in the polar region, what happens? It's found very high altitude, that is about 40 to 50 kilometers altitudes. This type of polar night jet stream prevails. It's also called as polar night jet stream because in the northern hemisphere polar region and southern hemisphere polar region, what happens? Especially in the northern region, you have the 6 months of winter season. So in that winter season, this jet stream emerges. Because of this, the name is called as polar night jet streams. Polar night jet stream also develops a strong thermal contrast between the subpolar and polar air. So the air which is blowing from the subpolar region and from the polar heights, that is, here you have the cool air, here you have the warm air. So you have the contrast between these two airs. So because of this exchange of this cool and hot, so you have the formation of this polar night jet streams. This flow becomes westerly under the influence of Coriolis force. So because of this Coriolis force, the direction of the wind is western side. Next one is cross equatorial or Somali jet stream. So this is also one of the interesting jet stream, that is the cross equatorial jet stream. So in the name itself you can understand that is it is crossing the equatorial region. It forms because of unequal heating of Africa. So in the African region, the Somalia is here. So you have in Africa region, you can imagine that there will be a high temperature. So here you have high temperature in Somali, and here you have the in the ocean you have the contrast, the cool air. So what happens? The wind which is traveling here will be diverted again this side because of the Coriolis force. So because of that, there is a because of the shift of the movement, apparent shift of the movement of sun, this air is again diverted towards the right side, towards the India subcontinent. This also plays a vital role in the formation of southwesterly winds, that is southwest monsoon winds. So these two factors, these two jet streams plays an important role in the onset of southwest monsoon in Indian subcontinent. Vertical wind shears, that is the jet stream cause strong vertical wind shears, that is it's most important in the formation and growth of these storms. The if it's going to be a vertical growth, what it leads to the clouds, which gives the precipitation. So cumulonimbus clouds, so that vertical clouds have been formed because of this vertical wind shears. So the rainfall pattern is also influenced by vertical wind shears. It leads to the cloud formation. It also affects the aviation safety, and it leads to the turbulence. Because of the turbulence in these latitudes, because of vertical wind shears, it adversely affects the flight travel, that is a flight path. So the flight safety is mainly determined by the vertical wind shears. So the impact of monsoon onset and strength is also determined by vertical wind shears. So vertical wind shears plays an important role in the weather process. Seasonal shift of jet streams. So the seasonal shift, that is the shift in north in summer and south in winter. So there is a shift. So this shift is mainly because of the heating process. So the differential heating process leads to this slight shift. It is driven by the temperature contrast between cold polar and warm tropical airs. So warm tropical air is in the lower latitude and cold polar air in the higher latitudes. So because of these contrast, this slight shift is there in this jet streams. It influences the rainfall and weather patterns also. The jet streams and climatic zones, that is the jet streams separate the warm and cold air masses. It separates the two regions, because see here you have the cold air, sorry, this is cool air. Here you have the warm air. So here you have the separation of this jet stream. So the jet stream separates two different air masses. They strengthen the mid-latitude weather system. So the mid-latitude, it is a zone of mixing. So because of that, mixing has taken place because of this jet streams. It also shapes the climate of temperate regions. So the temperate region have the diversified climate like winter, summer, autumn and spring. This happens because of the influence of jet streams. It influences the path of storm. It influences the path, how the storm is traveling. The path is determined by jet streams. It helps to distribute the heat across the globe. The global heat is redistributed or distributed with the help of jet streams. Jet stream and cyclones. So how cyclones and jet streams are associated? The deep trough intensifies the cyclones. So the trough nature which intensify these cyclones, it provides the divergence aloof to aiding the storm development. So because of this processes, the storm is developed in the cyclonic process. The jet stream streaks trigger this cyclogenesis, that is cyclone formation. It influences the path of these cyclones. So all the path, the cyclone path and then wind direction path, everything is determined by the jet streams. Can sometimes weaken the tropical cyclone also. In all cases, it is not very strong. So in some cases, it also weakens the tropical cyclones. The jet stream and weather system. How jet stream control the weather system, that is the cold wave and heat waves. So the heat wave and cold wave is controlled mainly by jet streams. It causes the prolonged dry and wet spells via atmospheric blocking. So we know that there is a blocking between the cold and warm air masses. So this blocking, it may lead either to the warm nature, or it may be in a dry condition, or it may be in a wet condition. So the wet spells and dry spells happens because of this atmospheric blocking. So blocking occurs when jet stream stalls, fixing the weather systems. So this blocking happens when it stay and moves or it travels across. So that stagnant situation highly influences this blocking nature. That is, it leads to the rapid and extreme weather changes. It also influences these snowstorms and blizzards are highly affected by or influenced by jet streams. Jet stream and ocean currents, that is, jet stream guides surface winds and drive ocean currents. So this ocean current, the ocean circulation, water circulation, is also mainly influenced by jet streams. It influences El Nino effect and La Nina events. So El Nino and La Nina is events are controlled by jet streams. It also affects the coastal upwelling zones, and it controls the interaction between storms and ocean. So it is a mediator between the storm and ocean. The jet stream plays an important role between the water bodies and wind. It shapes the marine and coastal climates. So the coastal region is highly influenced because of this jet streams. Jet stream and aviation. So if the flight is going to travel along the jet stream, what happens? It will be having the speed of the flight will be increased and it will reduce the travel time. If the flight is going to travel against, opposite to the jet stream, what happens? It will consume the fluvial, that is, the energy will be consumed because of the wind action. So in such a way, this aviation is highly influenced by jet stream. That is, the tailwinds from the jet stream reduces the flight time. Headwind increases the fuel consumption. So the jet strikes causes the turbulence risk. Because of that, the jet strikes, the turbulence risk have been caused. The jet stream are used in flight planning. If the flight have to be efficiently operated, what to be understand, that is, you have to understand, that is, pilot have to understand about jet streams. They influence the polar flight routes for the efficiency and safety. So the polar flight routes have been mainly influenced for the efficiency of aviation. Jet streams and weather forecasting, that is, the jet stream determine the storm movement. So all the path have been identified because of jet stream. It includes the numerical weather prediction models. In the weather prediction models also, this jet streams plays an important role. It have been included. That is, the satellite data, it monitors the jet stream speed and position. So based on the speed and position, we can track the weather event. And the jet stream streaks helps to predict the severe weather events. So because of the streaks, what is the weather condition, what is the weather pattern of that particular region can be identified. It assists in forecasting droughts and floods. So if a region going to be affected by droughts or by flood, that can be somehow predicted with the help of understanding of jet stream, in such a way that jet stream and weather forecasting is highly correlated with each other. Jet stream and extreme events, that is, heat wave, which results in the blocking of high pressure system. So there is a block. If there is a block, what happens? That is, it influences the heat wave. And there is also a cold wave, because due to the polar vortex collapse. Because of this polar vortex collapse, there is a cold wave. And the flood happens when trough stalls and move slowly. The flooding is happen because of trough stalls and then slow movement of the jet streams. The droughts are caused by persistent and high pressure ridges. So these are all the characteristics, features which is required for the drought condition, flood condition, which is highly influenced by jet streams. The jet streams triggers the strong wind and turbulence. The strong wind and turbulence is highly influenced by jet streams. So in such a way, the extreme events have been influenced by jet stream. Jet stream and climate change. The Arctic warming, that is, the polar region warming, weakens the jet stream. Because of the warming effect, it entirely have the adverse condition. That is, again, we have the cold air there. But if it's going to be warm, that warm air and warm air will be meeting. But what is the nature of the jet stream? The opposite air masses have to be meeting each other. So this adversely affect the climate change, and the result is more wavy meandering jet stream patterns will be there. So there will be a wavy pattern of jet stream which leads to increased extreme weather events. So because of this wavy in nature, that is, it increase the extremity of climatic condition. Slower jets cause prolonged weather systems, that is heat waves, storms, and the shift in the jet streams latitudes is predicted with the climate change. So the climate change and the jet stream is highly influenced each other. So if there is any change in the jet stream, it adversely affect the or influence the climate change. Importance of jet stream, that a jet stream steers storms across regions, that is, it impacts monsoon pattern and mid latitude weather system, that is southwest monsoon. It's have influenced the southwest monsoon, and it also determine the weather condition of the weather pattern of the mid latitude. And then it also affects the flight path and fuel usage in aviation. So we have also discussed about the efficiency of the aviation is because of jet stream. It plays an important role in distributing temperatures worldwide. So the temperature is distributed and redistributed because of this jet stream. It acts an important marker of monitoring climate change. So the climate change is one of the important factor which have been monitored with the help of the jet streams. To sum up with the entire lecture, that is, jet stream are narrow band of very fast wind found in the upper troposphere, flowing from, generally it flows from west to east. The altitudes of it is 9 to 16 kilometer. They form along the strong temperature pressure gradients. Mainly it occurs as the polar jet and subtropical jet streams. These jet streams plays a crucial role in controlling storm tracks, monsoon, aviation routes, and overall weather system. Hope you have understand the entire concept of jet stream. In the upcoming lecture, we will be discussing on local winds. Thank you.